Hello everyone. In this video, we are going to discuss about stoichiometry and stoichiometric calculations from the chapter 1 class 11 chemistry, some basic concepts of chemistry. See, the word stoichiometry, it is derived from two Greek words stoichion and metron. Stoichion meaning element and metron means measure. So you see, stoichiometry, it deals with the calculation of masses, sometimes volumes of the reactants and the products involved in a chemical reaction. See, stoichiometry, it deals with the amount of reactants and amount of products in a chemical reaction. Let us consider a balanced chemical equation. That is, here we are considering the combustion of methane. So the balanced chemical reaction of this is the methane gas, CH4 gas, it reacts with 2O2, that is methane and oxygen. They react and gives carbon dioxide and water vapor. That is here methane and dioxygen, they are the reactants. Okay, and carbon dioxide and water vapor, they are the products. Here you see all the reactants and the products, they are gases. It has been indicated by the small letter G in the bracket next to this formula. That is, here we have methane gas reacts with dioxygen, that is oxygen gas, and it gives carbon dioxide gas plus water vapor. Similarly, for solids and liquids, we will write, for solids within brackets we will write S, for liquids we will write L within brackets. Now you see, what are the coefficients of reactants and products here? See the coefficient of methane, that is CH4, it is simply CH4 means 1 CH4. Okay, now what about the coefficient of oxygen? It is 2. Coefficient of carbon dioxide, it is 1. Coefficient of water vapor, it is 2. Okay, so you see, these coefficients, they are actually called as stoichiometric coefficients. That is, the coefficients of reactants and products, they are called as stoichiometric coefficients. They represent the number of molecules or number of moles taking part in the reaction or formed as a product in a chemical reaction. So, here we have this reaction. See, according to this chemical reaction, that is, you see, here the coefficient, the stoichiometric coefficients are 1 for methane, 2 for oxygen, 1 for carbon dioxide and 2 for water. These are actually the stoichiometric coefficients. Okay, see, according to this chemical reaction, we can say that is in terms of moles, we can say that 1 mole of CH4 gas reacts with 2 moles of oxygen gas to give 1 mole of carbon dioxide gas and 2 moles of water vapor. Okay, so you see these are actually the stoichiometric coefficients. By using those stoichiometric coefficients, we can, talk about this. That is, in terms of moles, we can say that 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. Now, from the same equation, from the same stoichiometric coefficients, in terms of molecules, we can say that 1 molecule of CH4 reacts with 2 molecules of oxygen to give 1 molecule of carbon dioxide and 2 molecules of water. Okay, similarly, in terms of mass, you see, here we are approximating the mass of one hydrogen atom as 1. It is actually 1.008, no? So I am taking it as 1. So for hydrogen, so 4 into 1, 4 gram, plus I am taking the atomic mass of this carbon as, its molar mass, I am taking it as, 12. Okay, so 12 plus 4, 16. So we can say that 16 gram of CH4 reacts with, for 1 oxygen, its mass can be taken as 16 gram. So for 2, it is 32. But 2 moles of or 2 molecules of oxygen is there. So 2 into 32. Okay. Then for carbon dioxide, 12. 2 oxygen, So 32. So 32 plus 12, which is 44. Okay. Then for 1 hydrogen 1. So for 2, 2. Oxygen 16. So 2 plus 16, 18. 2 such molecules are there. So 2 plus 18 or 2 into, not 2 plus 18, 2 into 18, which is 36. That is, in terms of mass, we can say that 16 gram of CH4 reacts with 2 into 32 gram of oxygen to give 44 gram of carbon dioxide and 2 into 18, that is 36 gram of water. Okay. Now, in terms of volume for gases, you see, we know that at STP, at standard temperature and pressure, 1 mole of an ideal gas, it occupies a volume of 22.4 liter. At standard temperature and pressure at STP, 1 mole of an ideal gas occupies 22.4 liter volume. So here you see we have 1 mole of methane, 2 moles of oxygen, 1 mole of carbon dioxide and 2 moles of water vapor. Okay, so in terms of volume, we can say that for 1 mole, the volume will be 22.4. For 2 moles, it will be 2 into 22.4, which is 44.8. So in terms of volume, we can say that 22.4 liter of CH4 gas reacts with 44.8 liter of oxygen gas to give 22.4 liter of carbon dioxide gas and 44.8 liter of water vapor. Okay, now let us consider one more example. Now, let us consider another equation. That is, here we are considering a reaction of nitrogen and hydrogen to form ammonia. Okay, so here the coefficients of reactants and products, you see they are actually called as stoichiometric coefficients. So the coefficient of nitrogen is 1 and 2. For hydrogen it is 3. Okay, for ammonia it is 2. Alright, so here the stoichiometric coefficients are 1, 3, 2. Because the coefficients of reactants and products, they are actually called as stoichiometric coefficients. Now you see, so here 1, 3 and 2 are stoichiometric coefficients. These actually represent the number of molecules or number of moles taking part in the reaction or formed in the reaction. So, according to this chemical reaction, we can say that in terms of mole, we can say that 1 mole of N2 gas reacts with 2 moles of hydrogen gas to give 2 moles of ammonia gas. Okay, in terms of molecule, we can say that 1 molecule of nitrogen gas reacts with 3 molecules of hydrogen gas to give 2 molecules of ammonia gas. Okay, now what about in terms of mass? You see, we are actually talking about the molar mass. Molar mass means mass of 1 mole. Okay, here we have 3 moles of hydrogen. See, molar mass is actually mass of 1 mole. Here we have 3 moles, so you have to consider that as well. And molar mass is actually equal to the molecular mass in gram. Okay, so for 1 hydrogen, we can take its molecular mass in gram. That can be taken as 14 for 1 nitrogen. For 1 hydrogen, we can take it as 1. Okay, so when you find out the molar mass of this N2, 14 plus 14, which will be 28. Okay, so 28 gram of nitrogen gas reacts with 3H2. Now for 1 hydrogen, 1. So for 2, 2. 3 2s are 6. So 28 gram of N2 gas reacts with 6 gram of H2 gas. Okay, to give NH3, 2 NH3. For 1 NH3, it will be 14 plus 3, 17. Okay, so for 2, it will be 34. Okay, that is 28 gram of N2 gas reacts with 6 gram of hydrogen gas to give 34 gram of ammonia gas. Okay, similarly, in terms of volume, you see at STP, 1 mole of an ideal gas occupies 22.4 liter of volume. So here we have 1 mole, 3 moles and 2 moles. So we can say that 22.4 liter of nitrogen gas reacts with 3 into 22.4, which is 67.2 liter of, okay, that is, here we can say that 22.4 liter of nitrogen gas reacts with 3 moles, no? So 3 into 22.4 liter, which will be 67.2 liter of H2 gas, okay, to give 2 moles of NH3, no? So 2 into 22.4, that is to give 44.8 liter of ammonia gas. Okay, I hope it is clear to you. So you see, from these relationships of mole, molecules, mass, okay, we can actually, you see the given data, this can actually can be in the converted as this. Okay, mass, number of molecules and moles, they can be, you know, they these data can be in the converter like this. Okay, now you see, when you find out the ratio of mass and volume, that is mass divided by volume, that will give you the density. All right. So in this video, we have discussed about the stoichiometry and stoichiometric calculations. I hope it is clear to you. Thank you.